Okay, so if you remember, I'll say recall, back to preview of chapter 6. You guys were looking at, gosh, I think that was number 6, was something similar to whatever this is. I'm making the numbers up. But 4/3 minus 3 halves, plus 3 halves. Something like this, and I told you how to treat it as two different problems. So your first step is get a common denominator of the lower denominator. Then solve that, and then your second step is to then write it as a division problem. And your third step is, as some people say, flip and multiply. Some people say invert and multiply, if I can spell. I say multiply by the reciprocal, okay? So that's what we were doing in those problems. Now we're going to go ahead and take a peek at having the complex fractions that have like rational functions in them. So what I mean by it is this problem right here. 5 over x plus 4 all over 1 over x plus 4 plus 2 over x. So now we're going to be mixing new things that you guys have learned. You guys learned how to add rational functions that have different denominators. And you guys learned how to divide rational functions. So we're going to be doing both in this problem. And this first step is we want to go ahead and basically treat what I just boxed in blue as its own problem. The reason why we're going to do that is because it's two parts and it's too confusing right now to leave separate. So we want to get a common denominator so we can add it together. All I have to do is I need to multiply this by x plus 4 over x plus 4, and then the other side by x over x. And now they have the same denominator. So what I have, I'm just going to pull this out. We'll come back to the 5 over x plus 4 in a second. I have x over x squared plus 4x plus 2x plus 8 over x squared plus 4x. Now we can put this together, and that gives us 3x plus 8 over x squared plus 4x. We are now going to take that and replace it into that piece because they are the same. All we did was add it together. So now we have 5 over x plus 4 all over that 3x plus 8 over x squared plus 4x. Now we're going to rewrite this as a division problem. Technically, we just solved that first step, and now we're going to be writing as a division. So let me kind of minimize this a little bit so I have more space. I need to go ahead and take this and rewrite it as a division problem. My work is slightly messy today, so I apologize. Got 5 over x plus 4, and rewrite it as 3x plus 8 over x squared plus 4x. Because a fraction over a fraction is the same thing as a fraction divided by a fraction, fractions are actually division problems. I hope you guys remember me saying that, or prior teachers, but if you didn't, now you do. So now we see it as this, which this is just what 6.3, the second half of 6.3 was. So you guys 100% know what to do, hopefully, on these next few steps. So we wrote it as division, and now we need to flip and multiply. So that gives us 5 over x plus 4 multiplied by x squared plus 4x over 3x plus 8. Now, if I wasn't a fool, I wouldn't have multiplied this together because now I have to refactor it out, which you guys have in the other problems. So that's 5 over x plus 4 times x plus 4 over 3x plus 8. Now we can see that the x plus 4s will cancel each other out. And you are only left with a 5x over a 3x plus 8. And you are finished with this problem. It looked terrifying, but now it's not as bad. But we cannot forget the things that make the denominator 0 in our original. We've got this x plus 4 and this x that set things to 0, and we also have that x plus 4. So x cannot be 0 and negative 4, because both of those, oops, change colors, both of those turn the denominator to 0 and make it undefined when we do this multiplying and dividing. All right, that's it on this one. So I believe next you guys are going to have an example to try on your own.